Dear students, today I am going to discuss about a very important aspect of amplifications, that is cascode amplifier. So as a matter of fact, a cascade amplifier has one transistor on the top, as we can see here in this particular slide, and this has been illustrated also in the figure I have showing in front of you. Here we can see that the transistor Q1 and its associated components operate as a common emitter input stage, whereas the circuit of transistor Q2 operate as common base output stage. Now this type of arrangement is designed to provide a high input impedance with low voltage gain. Why we should use? Just to ensure that the input Miller capacitance is at its minimum value with a common base stage providing a good high frequency operation. Now here in this figure, how to obtain the gain we can find out like this way, that the DC conditions of the circuit. It may be observed that the emitter current of the transistor Q1, it is set by VE1, as we can see from the figure, that VE1 is nothing but the voltage which is appearing across C2 and R4, right, in the left hand figure. Also, the collector current IC1 is approximately equal to IE1. Can we say it? If we can see the input current, and which is the current which is coming out of the transistor Q1. So IC1 we can say that which is approximately equal to IE1. Similarly, IE2 which is approximately equals to IC2. So this means that the current IC2 is approximately equal to IE1. Can we write? So this current IC2 will remain constant irrespective of any value of the voltage which is appearing across VB2, as long as the common emitter voltage 1, that is VC1, remains large enough for the current operation of the transistor Q1. As we have discussed earlier also, further the input impedance of the emitter transistor Q2, now it will constitute a AC load in the collector circuit of Q1. See from the figure, as you can see that the voltage gain, that is AV1, now we can write down is as minus HFE upon HIE into the Zin, that is input impedance, to Q2. So after calculating the values, we can find out AV1 equal to minus of 1. So thus, with a stage gain of only 1, that is unity gain, no Miller effect occurs at transistor Q1. So here from the right hand side calculation, I want to show you that the voltage gain of stage 2, it can be very well calculated by AV2. I can write down that is the voltage gain. So AV2 can be equal to of parallel resistances. Where the parallel resistances are there, we can see from the left hand side figure, that is R3 and RL. These are coming as parallel, the product with HFB upon HIB. So converting this to common emitter parameters, so overall voltage gain for the cascode amplifier now will be the same of a common emitter amplifier. So the overall gain we can write very easily, that A upon AV, that is A suffix V, we can write down it is as a overall voltage gain, which is nothing but minus H of FE into R3 parallel RL upon HIE. So this means that the cascade amplifier has high input impedance first of all, and the same voltage gain as a common emitter amplifier, which is very important. You need to remember that the same voltage gain it is offered by common emitter amplifier also, but very low input capacitance. So this is the very important aspect of this cascode amplifier. Thank you.